In the last video, we talked about the major functions of trigonometry, the sine function, and the cosine function, where both are taking some number of degrees, and they together answer the function if we went a certain number of degrees. Say if we went 15 degrees up on a circle of radius 1, how far would we move in the x direction, and how far would we move in the y direction? And the cosine was answering that question for our x coordinate, and the sine was answering that question for our y coordinate. And of course, because in our picture our circle has radius 5, we would just scale our values by 5. We would say this point here has positions 5 cosine of 15 degrees and 5 sine of 15 degrees. And yes. So in this video, I want to just explore some interesting facts that arise with the sine and cosine function as answering the question of the x and y coordinates of the unit circle. And first things first, I want to draw a graph of sine and cosine, because there's something very special that happens with sine and cosine that we have not seen up to this point. So here I have my x and y axes, and let's just say this is 1, this is -1, and you know what? Because we're doing on a circle of radius 5, let's say this is 5, this is -5, and here let's mark out some points. Let's say 90 degrees, 180 degrees, let's say 270 degrees, 270 degrees, 360 degrees, and let's do 450 degrees. And you could, in theory, continue this on and on. So let's draw a picture of, let's say our function here is y equals the sine of x. Y equals the sine of x. Well, at 0 degrees, as you can see, at 0 degrees, the sine of x, that's not 0 degrees, at 0 degrees, the sine of x answers the question, what is the y position at 0 degrees? Well, clearly at 0 degrees, there is 0 y position. So at 0, y will equal 0. But if we go to 90 degrees, we are purely y. So this entire 5 here, this entire radius of 5, will be going into the y. So at 90 degrees, we get 5. At 180 degrees, we again see that we have a y position of 0. So we go back to 0 at 180 degrees. But then at 270, we see that we have now a y position of -5. So we go down here at 270 to -5. And clearly at 360, we again have 0. And at 450, we again have +5. And you can see a pattern arising here. If we just connected the points with a slight curve here, you can see that we're going up and then down, and then up and then down, and this will in theory continue indefinitely for the entirety of the sine function. You will go up as the circle goes up, then you will go down, then you will go up, again and again and again. And this is significantly different. This is significantly different from the polynomials that we have seen before. If you remember, polynomials that we were looking at before, right? If you had a polynomial, it might have, let's say it's a cubic, it might come up from the bottom. It might have a bump, and then maybe it's a quartic and it has one more bump, but then it goes down back, and there will never be another bump. And if you had a degree, so let's do this in a line here. If you had a degree 2 polynomial, you'll have at least one bump, degree 2 being a parabola. So you'll have one bump on a degree 2. On a degree 3, you can have up to 2 bumps on a degree 3. Could look something like this. And on a degree 10, for example, you could have up to 10 bumps if you really planned things out with your coefficients. You could have like 1, 2, 3, 4, 5, 6, 7, 8, 9, and go on. And this could be degree 7 polynomial or somewhere whereabouts there. And you can see clearly with a finite degree polynomial, we can just never hit an infinite bumpiness. But clearly, the sine and cosine functions would have to go. They would have to go up and down an infinite amount of times, because otherwise, how would they be able to model a circle that, as you go to infinity, just oscillates up and down? And this can tell you something kind of amusing, interesting about the sine and the cosine function that we'll expand on when you start learning calculus, actually. But that the sine function, the sine function is, in some sense, degree infinite. It has an infinite degree in some senses, because no finite degree polynomial can make it, although finite degree polynomials can approximate it. Here you have the first two approximated. Here you have 3. Here you have many approximated. It's just an interesting tidbit about the sines and cosines that hopefully helps you understand where they are a little bit better.